A function is a set of pairs of input values and output values in which each input value gives out exactly one output value. For example, if you're asked the question, what is the capital of Singapore? The answer is Singapore City. It has only one answer. So it is a function. fx equals to 2x plus 1. We call this fx or f of x. We could have also called it g of x. It doesn't really matter. We could have also called this y equals to twice x plus 1. This is also a function. What you need to remember is the input value or the independent value x will give you, if you use it in this rule of twice x plus 1, an output value or the dependent value. The dependent value depends on the independent value. For example, if I put here 1, we would get a unique value 2 times 1 plus 1, which is 3. So the input value is 1 and the output value is 3. So this is a part of the domain and this is part of the range. Domain is the collection or set of all the input values that is possible. Range is the collection or set of all the output values that is possible. So let's take a look at a number of very common functions. First of all, let's think of f of x equals to x. If you think about it, for any input value, you will get an output value. So the domain can be any real number, and we write this as x is an element of real number. So this is the domain of the function f of x equals to x. The range or the output value can also be anything. It can be any possible value. So the range would be fx can be any real number. Another way of writing this down is thinking of the values of x as between negative infinity, meaning it can be any value on the number line in the negative side, to positive infinity, it can be any value on the positive side, and the domain can be written as open bracket negative infinity comma positive infinity bracket closed. That's how we write intervals. On the other hand, the domain, after the domain, the range would be f of x is greater than negative infinity and it is less than positive infinity. So the set of values of the range would be bracket open negative infinity comma positive infinity bracket closed. So that's another way of writing down the domain and range. The next common function f of x equals to x squared. Now here the possible domain can be any number. If you put any real number 1, you get 1. If you put 2, you get 4. If you get 3, you get 9. So any possible input values in the real number. So this is x is a real number. The symbol for the set of real number is two vertical lines like that and then r, set of real numbers. Now in case of the domain, you can see that the values of x squared cannot be negative. If you put -1, it becomes -1 whole squared and it becomes +1. If you put -2, it becomes -2 whole squared plus 4. It is definitely cannot be negative. The only thing it can be equal to, it can be 0. So that means in this particular case, the range can be equal to 0. That means the range f of x can be greater than or equal to 0, but in case of upper limit, it has no limit, it goes up to infinity. Since infinity is not a real number, we don't give equal to sign. So in other words, for equal to sign, we give this third bracket 0 to infinity. This is the interval that we write. So in other words, you can write the range of f of x is greater than or equal to 0. That is the range of the common function f of x is equals to x squared. Now it would be a good idea to see what it looks like visually. Now first of all, if we take a look at y equals to x or f of x equals to x, we see any values of x is possible. and any values of fx if you follow the vertical axis, that is also possible. For that particular reason, we see that the domain is x can be any real number, and also the range is f of x can be any real number. Now if we take a look at the other function x squared, then it turns out to be the values of x could be any value here, any real value, but the value of the range, it is 0 is the lowest value. It cannot be negative. So visually now we can see that it is f of x is greater than or equal to 0. Another common range and another common function is f of x equals to square root of x. Now square root of x, the domain cannot be possible for any possible values of x. If you put a negative value, square root of a negative value, that's not possible. We cannot calculate this. Let's check. So if we have a square root over here, square root of -1, that is a math error. We cannot calculate square root of a negative number. We can calculate square root of 0, that is 0. We can calculate square root of 5, that's a positive number, but we cannot calculate square root of any negative number. That's a mathematical error. That means when we are writing the domain, the value of x, whatever happens, it has to be either 0 or greater than 0. In other words, the domain has to be greater than or equal to 0, and on this side it could be going up to infinity. It doesn't really matter. So we can write the domain with the third bracket, comma, infinity, bracket closed. So that's how we write the interval. So here the domain is going to be x is greater than or equal to 0. That is understood. Everything in the real value that is either 0 or greater than 0. In case of range, square root of a number cannot be negative. First of all, that number has to be 0 or greater than 0. That is the domain. But the output value, square root of x, if we find a value, the value will always be positive. It can be 0 or it can be positive. If you check this visually, you can see square root of a positive number, square root of x, it looks like this. And 0 is the smallest value it can have. Below that, it is not possible. So if you follow the vertical line, it can only be positive. So square root of x has a range of fx is greater than or equals to 0. So that's what it is. Now f of x equals to absolute value of x. Absolute value means just the positive value. So when we take the absolute value of x, we can put in any value of x. That means the domain has practically no restriction at all. So we can write x is a real number. In case of range, the absolute value makes any values of x positive. That means if you plug in -1, absolute value of -1 is +1. If you plug in -3, absolute value of -3 is +3. That means in absolute value, it cannot be negative. It can be 0 or it can be greater than 0, but it cannot be negative. So the range is going to be fx is greater than or equal to 0. Let me show this visually. So this V-shaped graph is the absolute value of x. So we can see here that the lowest value on the vertical line, the y-axis of the fx, it is 0. It can be positive, it can be greater than 0, but it cannot be lower than 0. So the range or the output values can either be 0 or greater than 0. The next common function is f of x equals to e to the power x. E is the number 2.718 and e to the power x. So when we put the value of x, we can get any output value. So the domain will have no restriction whatsoever. So x is a real number. Now in case of the range, if you take a look at the visual graph of e to the power x, what you see is that there is an asymptote over here. So if you take a look at the picture, it becomes parallel to this line. If you zoom in, you will see it does not actually touch this line. It goes very near the line, near the x-axis or the line y equal to 0. X-axis means the line y equal to 0, and that is known as the asymptote of that graph. So visually it looks like this. This is the asymptote, and the e to the power x barely touches that, and this line is y equals to 0, meaning the value of fx cannot be equal to this value. It has to be greater than this value. So in this case, it would be greater than the asymptote, greater than 0. This is the range of e to the power x. Then when we have f of x is equals to ln x, ln is the natural logarithm log base e. So here there is a restriction. If you check the calculator, you cannot find the natural logarithm of any possible number. So the natural logarithm of 1 is 0. The natural logarithm of 2, we get a value. Then the natural logarithm of 3, we get a value. So we got 1, 2, 3. How about the natural logarithm of 0? So the natural logarithm of 0 is mathematical error. How about the natural logarithm of minus 1? That's also a mathematical error. That means when we are finding the input values, it cannot be 0 or below 0. It can only be positive values. So the domain is going to be x is greater than 0. So that's the domain of natural logarithms. In other words, it means the domain can be greater than 0, or it can go upwards and go up to infinity, which we write as, this is the interval. So this is the domain of natural logarithms. The range, the output value, once you set up the domain, the output value has no restriction. So the output value can be any particular real number. So the output value is going to be fx belongs to any real number. In other words, it means it is going to be minus infinity to plus infinity. That is going to be the set of values for the output values. So this is the natural logarithm. Now there is one more common function that is a bit strange, and that one is a rational function. When we have f of x equals to this rational function, but we have a problem, because downstairs we have x, and there is one value of x that cannot be calculated, and that is no number can be divided by 0. So when we have 1 divided by 0, 1 divided by 0, we can see that it's a mathematical error. So x can be any value, the domain can be any real number, but the domain cannot be equal to 0. So the domain is, you can also write just not equal to 0, or you can write x is any real number except for 0. Now this particular function, it's a bit strange, so we cannot readily find the range unless additional information is given. For the other functions we can find the range without any additional information, but here we need additional information. Let me show you why not. So take a look here at the function of y equals to fx equals to 1 by x. Instead of one smooth curve, we have this separated two curves. So one domain, if you think about the range from here, from 0 to greater than 0, it is greater than 0, that is the range. From 0 to negative, 0 to less than 0 for values of x, the range is going to be less than 0. So there is a tremendous problem. How do we decide what the domain is going to be? So for this type of question, they're going to tell you find the range for this single domain. For example, the question might be find the range for x is greater than 0. So you have the picture like this, and for x is greater than 0, if this is 0, so this line is the asymptote y equal to 0. So this is the shape you have on this right hand side. So for this particular domain greater than 0, the range is going to be fx is greater than this horizontal line. On the other hand, if the question was find the range for x is less than 0, that means since there are two curves, separate curves, so this is going to be the case. So here, so this is 0, and this line, horizontal line, is y equal to 0. So here the shape is below this asymptote. So the range is going to be f of x is less than 0.